how many number of lines that will appear in the presence of magnetic field. So this problem is occurred in gauge physical science. The problem is the transition line as shown in the figure arises between 2d 3 by 2 and 2p 1 by 2 states without any external magnetic field. The number of lines that will appear in the presence of weak magnetic field is. So you know the term symbols in atomic state is represented as in superscript S plus 1 and L and subscript J. Here the 2s plus 1 gives the multiplicity of the state and J is the total angular momentum. And for this atomic state, if there is a transition between any two states, will occur only it follows the selection. It is when delta S is equal to 0 and delta L is equal to plus or minus 1 and delta J is equal to 0 and plus or minus 1 and delta Mj is 0 and plus or minus 1. So here the given state is 2d 3 by 2. So for this case, from the term simple representation, J is equal to 3 by 2. So the number of state it can split is 2j plus 1. So it is 4. So it is split into 4 if it is in the presence of magnetic field. So Mj is equal to 3 by 2, 1 by 2, minus 1 by 2 and minus 3. Similarly for 2p half, J is equal to half, and so the number of states it can split is 2j plus 1, that is equal to. So it is split into 2 states with Mj is equal to plus half and minus half. So this is the case when there is a transition from D to P. Now if it is in the magnetic field, it is split into the D is split into 4 level and the P is split into 2 levels. Now we'll see what are the different combinations the transition is possible with the selection. So initially there is a transition from D to P. So here in that case, it is N is equal to 3 and L is equal to 2. A for D, L is equal to 2. So the possibility is it is 3 by 2. J is 3 by 2 and Mj. J and Mj is 3 by 2 and plus or minus 3 by 2 or 3 by 2 plus or minus half. Okay. And the final state is your 2p half. So here N is equal to 2 and L is equal to 1. And J and Mj combination is half plus or minus half. Okay. Now there is a transition from this initial state, that is from D to final state P, is possible with delta Mj is equal to 0 and plus or minus 1. So in that case, if you take the initial state should be 3 by 2 plus or minus 3 by 2 to half plus or minus half. So if there is a transition from this Mj is equal to plus or minus 3 by 2 to Mj is equal to half, then we can have this delta J is equal to plus or minus 1, or Mj is equal to delta Mj is equal to plus or minus 1. And similarly for the other case, next possibility is Mj is plus or minus half, 2Mj is plus or minus half. So in that case, delta Mj is equal to 0. And another possibility is there is Mj is equal to plus or minus half to Mj is equal to minus half, minus or plus half. So in that case, delta J is equal to plus 1. So from here to here, there are two lines, and from plus or minus half to plus or minus half, two lines, and from plus or minus half to minus or plus half, so it is two lines. So we can have 6 lines are possible. So the number of lines that appear in the presence of a weak magnetic field. So generally D to P without magnetic field, only one single line. And for when it is appear in the magnetic field, when B is equal to greater than 0, there is a transition from Mj is equal to 3 by 2 to Mj is equal to half. And another possibility is mj is equal to minus 3 by 2, mj is equal to minus half, and mj is equal to half, mj is equal to half, and here it is mj is equal to minus half to mj is equal to minus half, and mj is equal to half to mj is equal to minus half, and mj is equal to minus half to mj is equal to half. So it is, we can get 6 different lines. So the number of lines that will appear in the presence of weak magnetic field is 6 in this case. Thank you.